The .NET Framework uses streams to send data to a variety of different medias. For example, the most common use is to use a stream to send data to a file in the file system. You can do this using several different stream variants, such as text writer or binary writer. The most basic of those is the stream writer class. Using stream writer, you can specify a file name in the constructor, and then you can use the streamwriter.write method to save data to that file. If you need to read that file later, you would use the streamReader class. You can also layer other classes on top of streamwriter. If you want to write a compressed file, you would create an instance of the gzip stream class. Then, when you create your streamwriter class, you provide that gzip stream instance as part of the streamwriter constructor. Then, anytime you call streamwriter.write, that data is funneled through the gzip stream instance. Gzip stream compresses the data using a type of compression called gzip compression. When you need to read the data back later, you can't just use an ordinary stream writer, or it will come back, the data will come back as gibberish. So you'll need to do exactly the same thing in reverse. You create a gzip stream instance set to decompress the data, and then create a stream reader instance using your gzip stream instance. Then you'll be able to read directly from the compressed file. The .NET Framework actually provides two different compression methods for writing compressed files. The one most people use is gzip that I just discussed. It's a more effective compression method than the deflate compression method. They're just different algorithms. They accomplish basically the same thing. Gzip is more common. It's even built into the file system. Deflate is a little less common and a little less efficient. So either one will compress a file, but the compressed file will probably be a little bit smaller if you use gzip. Now, the beauty of using streams is you can write to a variety of different media, not just the file system. In the .NET Framework, you probably won't write to the file system all that often unless you need to save a file for use in a different application. Instead, you should use isolated storage. Isolated storage is stored on the file system, so it is permanent. You can close your application and relaunch your application, and the data will still be there. Isolated storage, in fact, is a file on the file system, but the .NET Framework treats it as its own entity. So an application can write to isolated storage and read it back almost like it was part of the file system, but it has some benefits that the file system, that writing directly to the file system doesn't provide. First, isolated storage is protected by the .NET Framework. Different users cannot directly access isolated storage. Different assemblies cannot directly access another assembly's isolated storage. Perhaps most importantly, using isolated storage works well with the security principle of least privilege, because it takes fewer .NET Framework privileges to write to isolated storage than it does to write directly to the file system. If you are writing a file that will only be read back from your assembly and from the same user, you should always write to isolated storage instead of writing directly to the file system. When you use isolated storage, you can protect it in two different ways. You can specify the user domain, which means that only that assembly run by that user can access files saved in the isolated storage, or you can create the isolated storage file stream for the application domain. If you do it for the application domain, other assemblies running in the same application domain can access the same isolated storage. Application domains really only become important when you're writing multi-threaded applications or applications that spawn new assemblies, that launch new assemblies. So at this stage you probably won't use it, but we will discuss application domains in later modules. Another way to use streamwriter is to write through the memory stream class. Just as we discussed when using gzip stream or deflate stream, you will create an instance of memory stream. and then specify the instance when you create your StreamWriter instance. Then, anytime you call StreamWriter.write to save data, it'll be processed by the MemoryStream class. MemoryStream completely bypasses the file system and stores the data in the computer's RAM. In the memory itself, so it's not persistent. If you save data to a MemoryStream instance and the user closes the application, the data is gone. If the computer shuts down, the data is gone. It's stored in the computer's memory, so it is only persistent while the application and the computer are running. For that reason, you wouldn't generally use MemoryStream unless you need to prepare a stream to be written to the file system later. For example, if you need to gradually create a file over the course of 5 minutes, perhaps you're querying a database server and processing data and then outputting it to a file, you might write all that data to the MemoryStream, and then once the entire file had been processed, you could copy the MemoryStream to the file system using another instance of StreamWriter. That would be useful in applications where multiple users might be sharing a single file, or when you want to minimize the number of writes that you make to a particular file. So think of MemoryStream as a way to pre-write data to a file. But remember, it's not backed by the file system. So if your application is interrupted, it's gone forever.